Hello everyone, my name is M. Faningar Reddy and I am a student of Electronics and Communication Engineering at Sri Venkateswara College of Engineering. I am here today to present my seminar on autonomous vehicles with a 6G based intelligent cybersecurity model. As technology advances, autonomous vehicles are becoming more common on our roads and it is crucial to ensure their security and privacy. In this seminar, I will be discussing the proposed model's methodology and evaluation results. Thank you for joining me today and I hope you find this presentation more informative. Today I am excited to present my seminar on autonomous vehicles with a 6G based intelligent cybersecurity model. As we know, autonomous vehicles are rapidly gaining popularity and are expected to revolutionize the way we travel. However, with the rise of autonomous vehicles, there is also an increased risk of cyber attacks which can have severe consequences. In this presentation, I will be discussing how the proposed 6G based intelligent cybersecurity model can address these challenges. So these are the contents I will be discussing. Let's get started with the introduction and later on objectives, literature review, working principle is nothing but methodology, and after that results, applications, conclusion and references. So coming into the introduction, let's divide my title into three parts. The first part is the autonomous vehicles, and the second one, the 6G based wireless technology and cybersecurity model. Coming to the first one, the autonomous vehicles are rapidly gaining popularity as they have the potential to transform the way we travel and transport goods. We know that the autonomous vehicles are booming now. What exactly the autonomous vehicles is, you all know about Tesla and how it works. The Tesla works with the principle of autopilot mode, and these vehicles are equipped with advanced sensors, machine learning algorithms and communication technologies. And with these technologies evolving, there will be more concern on the cyber attacks and cyber security issues, and there will be cybersecurity threats such as hacking, data breaches, and privacy concerns are significant barriers to the widespread adoption of autonomous vehicles. So, to address these challenges, the researchers have proposed various cybersecurity solutions, including the use of 6G wireless technology, which offers high speed and low latency communication capabilities. So, in this paper, we propose an intelligent cybersecurity model based on 6G wireless technology for autonomous vehicles, which aims to provide a secure and reliable communication environment for autonomous vehicles. In this, the model leverages the capabilities of 6G networks and uses machine learning algorithms. The model is designed to be intelligent, adaptive, and scalable. This model is mainly suited for the rapidly changing landscape of autonomous vehicle technology. Here we are going to discuss the main objectives of this paper. The first objective aims to develop a cybersecurity model that is capable of detecting and preventing cyber threats in real time. This is essential for ensuring the safety and security of autonomous vehicles. The model should be able to identify potential cyber threats and take proactive measures to mitigate them before any damage can be done. This is crucial for building trust among users and ensuring the widespread adoption of autonomous vehicles. And coming to the second one, the second objective is to secure the services of all devices integrated within autonomous vehicles. This includes not only the onboard systems but also the devices connected to the vehicle, such as smartphones and other IoT devices. By securing all services and devices, the model can ensure that the entire autonomous vehicle ecosystem is protected from cyber threats. Coming to the third one, it is to improve the reliability of devices, which would avoid unnecessary vulnerabilities. And we have to make sure that they gets updated regularly, time to time. And the best example is our smartphone. If we relate our smartphone to in the real world, we will be getting our daily updates or monthly updates. We have to update it regularly. By improving the reliability of the devices, the model can reduce the likelihood of cyber attacks and improve the overall safety of autonomous vehicles. And coming to the fourth one, It is to create a cost-effective cybersecurity solution that can be implemented by a wide range of autonomous vehicle manufacturers and users. This is important because it will enable the widespread of adoption of autonomous vehicles without significantly increasing the cost of production or ownership. A cost-effective solution will also make it easier for manufacturers and users to comply with regulatory requirements for cybersecurity. Here next comes the literature review. It is very important to have a literature review so that we can able to know about the past, what exactly has happened about our technology and all. I have taken 6 literature review papers. The first one is Security and Privacy Issues in Autonomous Vehicles by Mohammad Khataba in the year 2022. The main advantage of the paper is it provides a comprehensive survey of security and privacy issues in autonomous vehicles, and the disadvantage is lacks empirical evaluation or testing of the proposed solution and countermeasures. And coming to the second literature review, a survey of cyber attack countermeasures for unmanned aerial vehicles by Peng Yong Kong in the year 2021. The advantage is provides an overview of the various types of cyber attacks that can be launched against UAVs and their potential consequences. And the disadvantage does not provide a detailed analysis of specific countermeasures or their effectiveness. Here is the third literature review, Attacks on Self-Driving Cars and Their Countermeasures, a survey by Abdullahi Chowdhury in the year 2020. There is an advantage as it provides an overview of the types of attacks that can be launched against self-driving cars and the countermeasures that can be applied to prevent these attacks. And the disadvantages are the effectiveness of some of the proposed countermeasures may be difficult to assess without further research or real-world testing. And the fourth one is Cybersecurity in Connected Autonomous Vehicles by Prinkil Sharma in the year 2022. The advantages are highlights potential solutions and future research directions in the field, and the disadvantages are limited to attacks and countermeasures. The next one is the Intelligent Attacks for Secure Communication in Autonomous and Connected Vehicles by Joheb Hassan in the year 2020. The advantages are it provides a solution for detecting and mitigating black hole attacks in autonomous and connected vehicles. The disadvantages are the proposed solution only focuses on black hole attacks and may not address other types of cyber attacks. There will be a lot of attacks in the autonomous vehicle regarding the cyber attack, but it is only focusing on black hole attacks, not on cyber attacks. The next literature review is on vehicle life interaction in fog enabled smart connected and autonomous vehicle by Bushra Feroz in the year 2021. The advantages are the fog computing can provide real time processing of data, allowing vehicles to make faster decisions and response to changing road conditions. The disadvantages are implementing fog computing in vehicles can require significant hardware and software upgrades, increasing the cost and complexity of the system. Here comes the working principle or methodology. We are having 5 main steps. In this methodology, it outlines the steps involved in developing the proposed cybersecurity model for autonomous vehicles. The first step is to identify the requirements, which involves understanding the potential risks and threats associated with cyber attacks on autonomous vehicles. The second step is to develop the architecture of the model, which involves the defining of components of the model and how they will interact with each other. The third step is to implement the model by developing the necessary software and hardware components and integrating them into the autonomous vehicle. And the fourth step is to train the machine learning algorithms that will be used in model. This involves collecting data and labeling it for use in the training process. The final step is to evaluate the performance of the model under various scenarios and refine it until it meets the desired performance criteria. This methodology provides a structured approach for developing and evaluating the proposed cybersecurity model. Coming to the proposed model diagram for the autonomous vehicles with a 6G based intelligent cybersecurity model. Here are the components connected as shown: service provider, policies, proactive autonomous vehicle future, users, and 6G based intelligent cybersecurity solutions. These are the major components in this proposed model. Coming to the first one, the service provider. This refers to the organization or entity responsible for providing services related to autonomous vehicles, such as ride sharing companies, delivery services, or public transportation agencies. And we can assume some good examples for service provider as Ola or Uber. And coming to the second one, policies. This refers to the set of rules and regulations that govern the operation and security of autonomous vehicles, including privacy policies, cybersecurity policies, regulations related to data collecting and sharing. This includes some protocols that should be followed by the autonomous vehicles as well. And the third one is proactive autonomous vehicle future. This refers to the autonomous vehicle's ability to detect and respond to potential cyber threats in real time. This includes features such as intrusion detection systems, data collection and labeling systems, machine learning algorithms, and autonomous response systems. And the fourth one is users. This refers to the individuals who utilize autonomous vehicles, such as passengers, drivers, or operators. And the final one is 6G based intelligent cybersecurity solutions. This refers to the advanced cybersecurity solutions that leverage the capabilities of 6G networks, such as real time threat detection, secure communication protocols, and edge computing. So, you all may be in doubt about the connections. So, the given clockwise direction of the diagram indicates the flow of information and actions between these components. The service provider sets policies for autonomous vehicles, security and data protection, and implements the proactive autonomous vehicle features in the vehicles. This is the flow. It will be in clockwise direction 1, and then policies 2, and then proactive autonomous vehicles feature 3. And next, the users interact with the autonomous vehicles and generate data that is collected and analyzed by the proactive autonomous vehicle feature. The 6G based intelligent cybersecurity solution provide the necessary security measures to protect the data and autonomous vehicles for cyber threats. It is the main one for the entire proposed model. So overall, the proposed model diagram illustrates the complex network of components and actions necessary for ensuring the security and privacy of autonomous vehicles in a 6G enabled environment. So this is all about the proposed model. So these are the components and the points related to the proposed model as explained above, and we'll go to the next slide. So next comes with the flow algorithm, how the system works. The flow algorithm used in this proposed model works in several steps to detect and respond to cyber attacks. The steps include the data collection, anomaly detection, intrusion detection, response mechanism, and continuous learning. So coming to the first one, the data collection. The model collects data from various sources such as sensors, cameras, and other autonomous vehicle components and labels them as normal or anomalous. So the second one is the anomaly detection. The collected data is then analyzed using machine learning algorithms to detect any anomalies or unusual activities that may indicate a potential cyber attacks. And third one is the intrusion detection. If an anomaly is detected, the model then initiates an intrusion detection system to identify the type of attack and its severity. And the fourth one is response mechanism. After identifying the type of attack, the model initiates an appropriate response to mechanism to mitigate the impact of attack. The response mechanism can range from simply alerting the vehicle operator to taking autonomous actions, such as shutting down the vehicle or rerouting it to the safe location. And finally, the continuous learning. The model continuously learns and adapts to new cyber threats, ensuring that it remains up to date and effective in protecting against the latest attacks. It should be updated on time. And overall, the flow algorithm used in the model works in a proactive and adaptive manner, detecting and responding to potential cyber attacks in real time to ensure the safety and security of autonomous vehicle and its passengers. And this is all about the flow algorithm. So coming to the results part, the evaluation of the proposed model demonstrated its effectiveness in detecting and responding to cyber attacks. The model was able to achieve a high accuracy rate in detecting various types of attacks, including DDoS attacks, black hole attacks, and intrusion attacks. In addition, the autonomous response system was effective in mitigating the impact of attacks and preventing any future damage to the autonomous vehicle system. Overall, the evaluation results indicate the proposed model has the potential to significantly improve the cybersecurity of autonomous vehicles. Like if we can compare with the strengths and limitations of the proposed model, one major strength is that its ability to detect and respond to cyber attacks in real time, which can help prevent accidents and thefts of sensitive information. Additionally, the model is designed to be scalable, meaning it can be implemented by a wide range of autonomous vehicle manufacturers and users. And it is also having some limitations as well. One limitation is the need for high speed and reliable 6G network coverage, which may not be available in all areas. And another limitations is the computational complexity of the machine. And these are all about the results, and next we'll go with the applications part. So here comes the applications of the proposed model. The first one is automotive industry. The cybersecurity model can be implemented in autonomous cars, trucks, and other vehicles to ensure the safety and security of passengers and cargo. And the second one is transportation and logistics. The model can be implemented into the transportation and logistics industry to secure the data and services provided by autonomous vehicles, such as real-time tracking and remote monitoring. And third one is military and defense. Autonomous vehicles are becoming increasingly important in the military and defense sectors. So the cybersecurity model can be implemented to ensure the security of sensitive information and prevent cyber attacks on unmanned vehicles. And the fourth one is smart cities. Autonomous vehicles are a key component of a smart cities. The cybersecurity model can be integrated into the infrastructure of smart cities to ensure the security of transportation systems and protect against cyber threats. And next one is healthcare. Autonomous vehicles have the potential to transform healthcare delivery. The cybersecurity model can be used to secure the data and services provided by autonomous medical transport vehicles, ensuring the safe and timely transport of patients and medical supplies. The next one is emergency services. It is related to healthcare, and autonomous vehicles can be used in emergency situations such as such and rescue missions. And the cybersecurity model can help prevent any cyber attacks on these vehicles during the any such critical operations. And finally, the agriculture application. Here, the autonomous vehicles are being increasingly used in agriculture as well, and the cybersecurity model can help prevent any cyber attacks on these vehicles, which can disrupt the critical processes involved in farming and agriculture. It may be related to all of these applications. And the 6G based intelligent cybersecurity model can be applied to a wide range of industries where security and safety of autonomous vehicles are very important. And these are all the applications of this model. And next comes the conclusion part. So to conclude with the conclusion part, this presentation highlighted the significance of developing an intelligent and adaptive cybersecurity model for autonomous vehicles. The proposed model leverages the capabilities of 6G networks and uses machine learning algorithms to detect and respond to cyber attacks in real time, ensuring the safety and security of autonomous vehicles. The evaluation of the model showed promising results in terms of accuracy and effectiveness. However, there are still limitations that need to be addressed, and future research should be focused on further improving the model's performance and scalability. And future research could focus on improving the model's performance by developing more efficient machine learning algorithms, reducing systems response time, and exploring the use of other emerging technologies such as edge computing and blockchain. So finally, this research offers a novel approach to addressing the cybersecurity challenges associated with autonomous vehicles and opens up with new possibilities for the development of safe and secure autonomous transportation systems. This is all about this paper and the presentation. So these are the references taken from the previous IEEE papers, which indicates the presence of cybersecurity and cyber attacks on autonomous vehicles. So thank you for your time and patience. And if you have any questions or queries, let me know in the comments. I will definitely reply for you. And if you like this content, please give me a like. And if you want this PPT, and let me know, I will give you the drive link which is password protected for you. Thank you so much. Thank you.